Rajveer Sheoran, Associate Professor in Chemistry, SRR, Morarka Government PG College, Jhunjhunu. First of all, good morning to all the students of MSc Final. अपन एंजाइम्स एक्शन एंजाइम वाली यूनिट अपन ने स्टार्ट कर रखी थी। उसी वीडियो लेक्चर के अंदर आज जो है अपन स्टार्ट करेंगे टेक्निक एंड मेथड्स ऑफ इमोबिलाइजेशन ऑफ एंजाइम्स। सो मोस्ट ऑफ द एंजाइम्स आर insoluble form and majority of them are used on single basis, particularly in food and beverage industries. For certain applications, it is desired that enzymes should be in solid or immobilized form so that these may be diffused and easily removed from the reaction mixture. Pharmaceutical industry especially requires this because enzyme step there can have the benefits of chiral resolution and environmental positive processing. The convenient removal of enzymes ensure better product recovery and minimum carryover of residual proteins. Enzymes have been attached to a large number of different physical forms of solid matrix such as beads of all size, micropulses, sheets, membranes and filter paper, and microtubes. These configurations make possible a number of reaction types such as fixed bed, fluidized bed, and shiny reactions. Immobilization technique. A number of techniques are available for enzyme immobilization. The choice is based upon application, whether the enzyme step is an aqueous or solvent medium at the beginning of the synthesis or hydrolysis process and the type of reaction. Adsorption on inert support is the simplest technique, but these supports do not permit permanent adsorption when used in aqueous environment without further modification. Lipase can be effectively adsorbed on hydrophobic support or for repeated use in non-aqueous lipid systems. So, adsorbed enzymes can be permanently fixed by cross-linking reactions with glutaldehyde treatment, which renders them reusable in aqueous solution. Cross-linking with glutaldehyde is a common technique. Supports such as cellulose or diastereomers each produce a product which is suitable for stirred reactors use and recovery by filtration. Thus, reactor can be used in also determines which physical forms of immobilized enzymes is to be used. Enzymes adsorbed on beaded supports are more suitable for common reactors or stirred reactions with simple setting is sufficient to remove the final reactant from the suitable catalyst. Now, immobilization supports. Many inert and activated supports are available for enzyme immobilization. Inert support such as resin produces glass beads, cellulose, gelatin, algains, or chitonesis requires chemical activation or deactivation prior to immobilization. Some activated supports can produce high enzyme loading with a high retention of activity. Many chemical activity supported, predominantly agarose-based, are available for laboratory research. Their large-scale use is not feasible on account of high cost only. Exceptions are antibody immunological applications. Chemical activity supports such as UTIP are available at large scale and are cost friendly. Enzymes can also be immobilized at high activity recoveries by simple entertainment where the enzymes is mixed with a soluble material that can easily be solidified. Such reactions include cellulose acetate precipitation from organic solvents to an aqueous change, acids to alkali change with chitosan polymers, temperature reduction with gelatin sodium to calcium change with allogenous chemical polymerization with polyacrylamides. The resulting interrupted enzymes is in fiber or beaded form. Enzymes in these forms have been used industrially for many years for resolution of amino acids and the chiral suppression. Effect of immobilization on enzyme activity. On the most of the important results of enzyme immobilization is increased stability both with respect to effective lifetime and temperature. Melrose compared stabilities of immobilized enzymes and their soluble counterparts. 30 of the immobilized enzymes were more stable, 8 less stable, and 12 showed to difference stability from soluble enzymes. So already reactivity is most important resolution of immobilization. Effect on reactivity includes altered kinetic constant resulting from a change in the activation energy, change in the pH optimum, Michaelis constant and specificity of the enzymes. If the solid matrix contains ionic groups, the microenvironment of the active site is changed by the electrostatic field. The field can affect the hydrogen ion concentration in the locus of the enzymes and thus change the apparent pH optimum of an attached enzyme. So a matrix change can also affect the apparent Michaelis constant of attachment enzymes if the substrate are also changed. For example, the apparent Michaelis constant is increased if the matrix and substrates have like change. Since the substrate is repelled by the matrix, conversely, the apparent Michaelis constant is decreased if the substrate and matrix are oppositely charged. So, applications of immobilized enzymes. First, most important application of this type of enzyme is in the synthesis of ATP, which utilizes acetyl phosphate as phosphate donor and immobilized enzymes as catalyst. This reaction occurs at room temperature and neutral pH. Insoluble polymeric catalyst can be easily removed by centrifugation and needs to be present in small amount and no byproduct adenosine tetraphosphate is formed as shown in the following reaction. Adenosine plus ATP, adenosine AMP plus ATP. Secondly, AMP plus ATP, adenylate kinase 2 moles of ATP. Then adenosine plus 2 ATP, it gives rise to 3 ATP. Then 3 ADP plus 3 acetyl phosphate in presence of acetate kinase, 3 ATP plus 3 acetate moles are present. Small amount of ATP is needed to initiate the reaction. All the three enzymes are immobilized to a cross-linked polyacrylamide gel by the reaction of their primary amino groups with active esters on the polymer surface. Cross-linking prevent denaturations from occurring under several conditions on manipulation and keeps the active site region intact. Now, secondly, these enzymes can also find the applications in the field of food processing. Then, thirdly, it can be polymer molder and to a magnetic stirrer bar is used to reduce lactose content of milk to overcome problems of lactose intolerance. This processed milk can be stored frozen for a long time without thickening and coagulating. Thus, these enzymes can be used in improving quality of food. Then cellulose from waste paper, wooden chips of sugarcane degrades to glucose and converts it back to starch, an edible material in presence of immobilized enzymes. Then mimicking carbohydrate synthesis by natural method also requires immobilized enzymes. Enzymes and coenzymes mobilized together can function as a self-contained unit to correct a metabolic imbalance. In Japan, mobilized enzymes are being used for enzymatic resolution and conversion of racemic mixture of optical isomer of amino acid to the natural isomer. These are also useful in medical field and pharmaceutical industry. For example, cortisone analogs prednisolone, which is used against rheumatoid arthritis, can be prepared by reduced cost starting with a steroidal precursor as shown in the following diagram or reaction you can see. Now these immobilized enzymes make the synthesis rapid, radioselective, stereoselective, as well as economically. They have resulted in lowering the cost of cortisone from 30 per gram in 1950 a few centuries per gram in 1970s. A second example is which is daily use is specific hydrolysis of natural penicillin G by penicillin amidase at preparative scale. These two involve chromatographic process. Hydrolysis of penicillin G this way produces 6 amino penicillinic and free from contaminants which can be used in the preparation of all kinds of semi-synthetic penicillin derivative. Here we can say this enzyme shows no loss activity even after 11 weeks of continuous use at 37 degrees centigrade. Moreover, this process is free from potential allergy producing contaminants. Now, component enzyme of a coupled system may be immobilized together, for example, and trapped in gel, or maybe separately and then they may be mixed together. Now, stirred tank reactors or packed bed reactors. This is the common process for this type of enzymes. These enzymes are valuable as model system, for example, to investigate properties of enzyme closely located in living system, for example, malate dehydrogenate or citrate synthesis system in mitochondria. Secondly, use of liposomes in investigating effect of lipids environment on activity of enzymes in vitro which are associated with membrane in vivo. Then lastly, last application is these type of enzymes may also be used in analytical system either in the dry reagents or automated techniques. So this completes our topic today. Thank you.